Okay, it looks like we're good to go. I guess I have the honor of keeping you from lunch by running over. So I'd better get started so I don't run over too much. And of course, then you will be able to hear the other people going for lunch. But I will keep you here forever. My name is Magnus Hagander. I'm here today to talk to you about Postgres version 12. Let me just start by, who has seen me do one of these new version of Postgres talks at PostgresOpen before? Okay, surprisingly few actually. I tend to do these almost every time because we do happen to make a Postgres release approximately every year. So the setup will be the same, but hopefully we'll be able to list actual new things because we haven't released Postgres 12 before. We try to keep each release once. A few quick words about myself. As I said, my name is Magnus Hagander. I work for a company called Red Pill Impro. We're an open source services and consultancy business in Scandinavia. So I'm out of Stockholm in Sweden myself, where I lead up our database efforts, which are unsurprisingly centered around Postgres. Otherwise, I probably wouldn't be here. Within the Postgres project, I'm a member of the core team. I'm one of the committers who supposedly writes the code. You can probably blame me for the bugs. And I'm also serving as the president of the board for Postgres Europe, which is the European equivalent of Postgres US, which is the organization that runs this conference. So I'm, among other things, involved in running the European sister conference of this, which will be in about a month's time in Milan in Italy. If you feel the need to get to the other side, please join us. We still have tickets. Anyway, enough about me. Let's talk about Postgres 12. Who's already running Postgres 12? No one. Come on, guys. Oh, OK, one person. You don't count. Now, as you might know, Postgres 12 isn't actually done yet, as if that keeps people from running it. But it's pretty close to being done. We hope to have it out pretty soon. We did actually make a new beta release of Postgres 12 yesterday. Who has installed that yet? Probably no one if you hadn't been running it. So the schedule of Postgres 12, what is about to become Postgres 12, started just over a year ago in July 2018 when we branched off Postgres 11. So the way that we work with the development in the Postgres project is we do all sort of feature development on the master branch in the repository. And then at some point we make this very bold statement and say, OK, this is now Postgres 11 stable. And by definition, it immediately becomes stable. And that's what then turned into Postgres 11. And when we do that, so this happened in July of 2018, that's when the master branch is renamed to Postgres 12. And features for Postgres 12 starts coming in. So at this point, if you were to look at the master branch of Postgres, it would say Postgres 13. Because we have branched that again in July for the next upcoming version. But then, of course, we spent some time stabilizing it. Now, during development in Postgres, we work with something that we call commit fests. And this is just sort of our term and our method for doing the iterative development, where the idea is we spend approximately a month doing feature development. And then we spend a month reviewing those features and getting them committed. And that's the thing that we call a commit fest. So for Postgres 12, we had 5 of them. We had one in July, one in September, one in November of last year, one in January, and one in March of this year. And at that point, Postgres 12 was sort of finished. Since then, it's been polishing, it's been bug fixing, it's been finishing the last pieces. And as I mentioned, right now the state is that yesterday we released the 4th beta version. And there are discussions ongoing right now about what's the schedule going to be for the final version 12, which will, it will be out soon. I'm not going to say it will be out before the end of the month because it's not that much left in the month. But there is nothing saying we're at least not going to be out before the end of the year. And I'm not going to tell you which year. But we're not going to release on New Year's Eve. I'll promise you that. So let's go into what we're actually doing. Let's start with the things that we broke. Because every new release breaks something, right? We're going to start with something that I hope does not affect you. But the data types abs time, rel time, and t interval have been removed. Does anyone even know what this is? Yeah. So if you don't know what it is, you're probably not affected by us removing it. They've been deprecated since forever, and now they're actually removed. So that should hopefully not hit you. The second breaking thing that I like to mention, Postgres has now removed the support for disabling strong random numbers. I hope you never did that. But if you had a deployment that relied on you building Postgres manually and turning off strong random numbers, you can't do that anymore. But really, that should not be a problem. And that's really, we broke some other things, but this is not like when we did Postgres 10, when like a quarter of my talk was, here are things that are now broken, because we renamed a whole bunch of things and just, we made them more consistent, and in doing so broke the entire world, at least if you are DBA writing scripts against Postgres. And it's paying off now. So Postgres 12 shouldn't be breaking a lot of things. You should be able, like the upgrade process should be fairly painless. Of course, the way to find that out is for you to actually upgrade it and let us know if it worked. But it's not supposed to be that painful. So let's look at the things we've added instead. And when I look at these, I tend to group it into sort of 4 groups. I'm going to talk about DBA and administration features, SQL and developer features, backup and replication specifically, and then performance, of course, because everyone loves performance. And I don't really know in a lot of ways, like what's the difference between a DBA and a developer in today's world? I really hope you don't necessarily have like, independent teams that don't talk to each other that do this. We're all supposed to work together. But I've just decided, I draw the line at, if it's exposed at the SQL level, then it's SQL and developer. And if it's like config file or similar, then it's DBA. And that's just a definition that's going to last for the upcoming 43 minutes and 12 seconds. But first, let me start with some tiny things. Who has ever used PSQL? OK, who has ever needed some sort of help with anything in the world, ever, right? So in PSQL, this is one of those tiny things that people have been talking about for a long time, and then it finally got done. When you hopefully all knew about the idea that you could do \h in a command, and you get the syntax for that command. That has been there forever. The thing that we have now is that it'll actually put out a little URL that you can click if your terminal allows to. That will bring you to the documentation page on the website that has the full documentation. It's a tiny thing. It turns out to be really useful. Previously, well, you went to the website, and then you would search, and then it's like now you just click and you're done, right? Very simple, very useful. And speaking of documentation, our documentation now has figures, like graphs and stuff. It's not just pure text. I think we have like 3 figures. But there will be more, right? The big thing here is, of course, we have the foundation to add more figures. And even today, I believe if you're looking at the version 13 documentation, there's actually more figures already. But in 12, it's not going to be that many. But we've started the process of making it a little bit less just text and adding some figures and graphs and things like that. So those are tiny things. Let's go into the actual features that you are able to use. So on the DBA and administration side, I'm going to start mentioning we have a view called pgstat_SSL that shows you SSL information about anybody who is connected to your system using SSL. It now adds the columns to get the client serial number and issue a DN, which can be really useful if you're using client certificates. You will be able to, from this view, see who is actually, like which certificate was used to log in on this connection. And the big difference is also that we are now masking the data for unprivileged users, and that is something that can actually break things. Just like with pgstat activity, if you connect with a non-super user or a non-monitor account, a lot of fields will just be empty. They'll be null, or they'll say insufficient privileges. That now also happens in pgstat_SSL. So you have to either be a super user, or a monitoring user, or the user making the connection. Then you will be able to see the data. But if you're any other user, the view will basically be empty for those connections. And speaking of SSL, we've also added config parameters whereby you can set the minimum and maximum allowed SSL protocol. The current values, you can set them to TLS version 1, 1.1, 1.2, and 1.3. And the defaults are that we go from TLS v1 up to anything. So at this point, 1.3. Postgres doesn't support anything before TLS v1. That's just disabled, and you can't enable it. And of course, we'd all like to set this to TLS v1.3, and you should do that if you can confirm that all of your clients have a new enough OpenSSL to actually support TLS v1.3, which a lot of people don't, which is why the default is still TLS v1. But it lets you increase the minimum TLS level if you have the ability to do so. And on the topic of connection and encryptions, Postgres now supports GSSAPI encryption. We've supported GSSAPI for authentication for a long time, and you could combine it with SSL and TLS for encryption. But if you have a well-working and set-up Kerberos environment using GSSAPI, you can now get encryption natively in that and not have to set up SSL. A typical example of the GSSAPI environments are, of course, people using Active Directory, which is not exactly uncommon today. And if you have that, the system already has all these encryption keys set up. And by using GSSAPI encryption, you can use that, and you don't have to set up certificates and all that stuff. It'll just work. If you don't have GSSAPI and you are just looking for encryption, use SSL. But if you already have it, or if you have the infrastructure, it's a great way to get that easier than you get it with SSL. Now, unlike SSL, GSSAPI encryption requires you to use GSSAPI for authentication, whereas SSL can use any authentication. It's a separate layer. And along with this, you also get a pgstat GSSAPI that then works the same way as pgstat SSL, but brings you in the information about the GSSAPI connection instead. So let's talk about it. This version's improvements of vacuum. Every version improves vacuum one way or another, right? And everybody loves vacuum, so you run it all the time. The vacuum command has now added the ability to get the parameter called skip locked, where you can say vacuum everything except the things that are currently being locked. Just skip those instead of blocking and waiting. This is for your manual vacuums. And then you can sort of run that more frequently, and eventually something will hopefully be unlocked and all that stuff. There is also a flag for vacuum called disable page skipping, which bypasses. So the way the Postgres works in recently modern versions is that it looks at the visibility map, and there is data there that says it can just skip vacuuming these pages because we know that nothing has happened here. They're all visible. There is nothing changed. And you can turn off that optimization by giving this flag. This is typically necessary for debugging if you have corruption issues with your visibility map, which hopefully you don't have. But it is a new flag and lets you do that. There are a couple of other useful improvements to vacuum. The vacuum db command, if you're running the command line tool to vacuum multiple tables, for example, to vacuum your whole database, you can now say min xidh and min mxidh. So basically you can say vacuum every table in my database that hasn't been vacuumed for 200 million transactions or 250 million transactions, instead of having to figure that out separately and then feed it the list of tables. And mxid is the same thing, but for multi-exacts. Now, I'll just repeat what I usually tell people who ask, which is you probably, like most people don't need this because most people will just handle this with auto vacuum. But if you are in a position where you need to complement auto vacuum with manual vacuums, this can give you another tool in the tool chest to figure out exactly when different tables end up getting vacuumed. Because as anyone who's sort of run a substantially sized Postgres database knows, if your vacuum doesn't work, nothing works. The copy command has received a where clause. What that means, well, this is the copy into the database. When you've copied data out of the database, you've been able to say copy and then just give it a SQL query with a where clause and say copy the result of this SQL query to a CSV file. But we can now apply a where clause to reading from a file. So in this case, we're saying copy my table from this my file with CSV where a equals 5. And it will then just read the whole file and apply the where clause to that file. Now, you can't put anything in the where clause. It has to apply to this row. You can't do fancy joins and recursive queries and things on your copies, but it lets you do the simple level filtering at an early stage. In a lot of cases, the way you did before, well, you loaded it into a temp table, and then you did insert into my main table with a where clause, and now you can just skip that temp table and apply the where clause directly. So again, small feature, very useful. Related to that, the PSQL command has learned to natively do CSV. It has a whole bunch of different formats these days. It has the standard format. You can get like HTML tables. I believe you can get LaTeX output and all sorts of weird things. And now you can add CSV by basically saying pset format CSV, and every select you do will just come out as CSV. Maybe useful. I'm not entirely sure when I'd use that myself, but hey, it's there. Who's using pgstat statements today? Okay, that's a fair number. Who has never heard of or never used pgstat statements at all? Okay, this is getting better. It used to be that 90% of the people put their hand up on that, and that makes me sad because pgstat statements is awesome. And you should all be using it. Or you should have a really good reason for not using it, and it shouldn't be, oh, I didn't know that existed. But it should be a good one. So pgstat statement has now gained the ability to reset individual query statistics. Previously, you could reset everything. Now you can go pinpoint and say, there's one query, just reset this query so that I can run my application and see what changes, because maybe you changed your schema in a way, you created an index, you removed an index, you want to look at what the new statistics looks for this. You can just reset this one query. And you just pass the pgstat statements, reset the query ID, and this wonderful number, that's the internal hash number in the form of a 64-bit integer, and it'll reset that one thing. You can, of course, still just say pgstat statements reset and reset everything. But that does, as you say, reset everything. We've added support, and I'll put a little disclaimer on this one. Postgres has had there's a pgstat progress vacuum view already. That'll tell you how far along a vacuum is. There has been views added for create index, reindex, and cluster. That lets you see how far into a create index process, for example, we are. Now, there are discussions right now going on about reverting this in Postgres 12 and removing it again, because issues have been found with the implementation that may not be fixable on time. So of the features I'm mentioning here, I think this is the one that has by far the biggest risk of not actually making it into version 12. If it doesn't, then hopefully it'll get fixed and added back into version 13, of course. But no guarantees. But if it does work, and if it does get in, it is useful in the end, because who has never run a create index and then like, oh, okay, how far along is this thing? Like, how long is this going to take? Did it get halfway in 10 hours, or did it get 1/10 of a way in 10 hours? And so it's very useful information to have. But there are issues with it if you happen to create another index while you are creating an index, for example, in a different session, and then the whole progress gets confused. So we'll see about that one. But if it does get in, I do believe it'll be very useful on larger systems. Another thing that we finally got into Postgres 12 that I think for many years have been one of our most requested features is reindex concurrently. We've had for quite some time the ability to say create index concurrently and create an index without exclusively locking the table for a long time and stopping your application. But if you needed to reindex, you couldn't do that. And the workaround has been, well, use create index concurrently to create a new index and then drop the old one, which works in a lot of cases, but it doesn't really work if this is a key, because then you end up dropping your primary key and you have dependencies of foreign keys on it. And the amount of really ugly workarounds that people have done to work with this is painful. And now you can just say reindex concurrently. It's very convenient. Of course, a reindex concurrently takes longer than a regular reindex. That's how it works. But that doesn't really matter, because it doesn't lock your system while it's running. Who is running their database with checksums, data level checksums on today? Who is not running that because you can't turn it on once you've set up your database? So Postgres 12 will let you turn it on. Unfortunately, it will require your system to be offline, but at least you don't have to dump reload. You have to shut down your system, and then you can use the PG checksums tool and say enable checksums on my database. It is going to rewrite the whole database. So if you have a large database, it will unfortunately be a long amount of downtime. There is a way to do it without a lot of downtime. If you have a master and a standby and you do things in exactly the right order, you can take them online, offline in a controlled fashion and actually have very little downtime using this. Of the whole cluster, you will, of course, have non-redundant as it's running. And also, if you use the PG checksums tools, which is just a rename of the PG verify checksums tool that you had before. It's now been renamed to PG checksums because turning on and off checksums is not verify. But if you're using the verify mode of it, you can now get a progress report. So it'll tell you how far along it is. So it's a step on the way. We hope to have in the future full online ability to turn on and off checksums, but not yet. And offline's at least better than nothing. And then we have, on this side, I'll say what might be at least turning into the one of those features that everybody talks about in Postgres, and it's actually completely useless in this version. It's not completely useless, but you're not going to be able to use it for anything, which is that we'll have pluggable access methods, letting you basically have pluggable storage engines in Postgres, except you're not going to have workable pluggable storage engines in Postgres version 12. It's not complete enough. It's a lot of infrastructure work. And hopefully it'll be enough so that when Postgres 13 ships, you'll be able to actually use it. But we've had a number of cases of this with Postgres. If any one of you went to Simon's talk this morning about partitioning, there was a lot of talk in Postgres version 10 about partitioning, but in reality, it wasn't good enough for most people until version 11. We had parallelism in Postgres version 9.6 that very few people could actually use, but then in version 10, suddenly it started working well. And I have a feeling that it will be the same thing here, right? This is not going to help you in version 12, but it's excellent marketing material. But then in version 13, hopefully it'll come out, and we already have 2 actively developed community-level storage engine, one that's undo-based, sort of similar to how Oracle does it, for example, and one that's a columnar store. And with luck, we'll actually have both of those for Postgres version 13. But don't get your hopes up in thinking this will be actually useful to you as end users in version 12, because it won't. So let's take a look at the SQL side. And let's start with things that we break, because it's fun to break things. You can no longer create a table with OIDs. Has anyone intentionally created a table using the with OIDs clause in the past 15 years? Oh, not just to test things? Yeah. So with OIDs, you probably all know what OIDs are like. These are the object IDs. They're all over the system catalogs, all over the system tables. And if you created a table and said with OIDs, it would add a column at the table called OID that would have this global 32-bit counter. Global and 32-bit and counter, it's not a good combination of things today, right? 25 years ago, that was probably fine, because nobody had that many rows in their database. But this would literally put a 32-bit limit on the number of rows across all of your tables. And after you wrapped that, bad things started to happen. So this has just been removed. It has been deprecated since 2005. Don't tell us we don't keep things alone for you for a long time, but it's now actually gone. That also means that OID is now a regular column. All the magic is gone, including in the system tables. The visible difference there is if you do a select star from PG class, for example, you will now actually see the OID column. Previously, you had to say select OID comma star, and you would see the OID column. It's just weird magic. The main thing that has also allowed us to do, there is also a lot of a lot of magic on the backend side internally in Postgres that special case the OID column, and all that code has just been deleted. Deleted code is like the best kind of code, because it can no longer have any bugs. And in the end, I believe this was sort of the actual removal was triggered by this pluggable storage API, because otherwise they'd have to re-implement OIDs for every storage engine. And today, re-implementing a feature for something that was deprecated in 2005 just didn't seem right. Another useful thing exposed at the SQL level is generated columns. This is something that's in the SQL standard, and of course, the SQL standard is always not entirely complete, and different databases do it different ways. But the way this is, we create a column that is the result of a computation. So it's a column where you can't put your data in it, but it's the result of a computation. Now, Postgres only supports stored generated columns, where we actually store the value. There is also something called virtual generated column, where every time you select, it would calculate the value. So a virtual generated column would be something like, it's sort of a mix of a table and a view. A stored generated column is more like, it's like a table with an automatic trigger that always calculates this value and you can't overwrite it, kind of a thing. So if you put it in this simple example, well, create table, it has a column A and it says B, generated always as A times 2 stored. Every time you insert a value, it'll just multiply it by 2 and store it in the different column. If you update it, it'll multiply it by 2 and store it in a different column. Now, if your computation is as simple as this, you should probably not use a generated column, because it will still store it, and that's expensive. But if you're doing an expensive calculation, then using this will just make it easier. Like you're storing large byte-A objects, and you want to store the SHA-1 of it. Excellent example for a generated column, right? Because you can't forget to update the SHA-1 when you are using a generated column. The system will just do it for you. Sorry?
What functions can it call?
It should be able to call any function that's stable. You obviously can't call volatile functions. You can't have it computed as current timestamp or something. That's different. But other than that, it's I don't believe you can like reference other tables levels, but any general expressions. If you're using enums, sorry? So the question is, are there any plans to support virtual columns? I think so, but I don't know how far ahead those plans are. I don't know if the work has been started. If anyone's using enum, you might know it's been one of the very few things that you couldn't do if you opened a transaction. If you did a begin and then you wanted to add a value to an enum, that wouldn't work. You had to do it outside of the transaction scope, which was annoying for a lot of these tools that automatically generate migrations. Well, now you can, right? Now you can say begin, you can do your alter type add value, and it works. And you can roll back the fact that you added value. It's all very nice. Of course, you'll get a different restriction instead, which is you can't use it in the same transaction. But it turns out, again, in a lot of cases, this was a blocker for a lot of these tools that would automatically generate migrations, and they are perfectly fine with this restriction, because they wouldn't do that anyway. But being able to just add it within a transaction breaks out of a lot of the limitations of those tools. One of the bigger things that we have at the SQL level, which is why I haven't covered it in detail here, is something called JSONPATH. I think there was a different talk during the conference on JSONPATH. If it has already been, I hope you saw it. If it has been and you didn't see it, well, there is video. JSONPATH is a SQL standard way to query JSON. Like Postgres had JSON long before SQL standard had it. So we've had our own way of querying JSON with these somewhat weird to a lot of people like syntaxes of matching JSON document to JSON document. JSONPATH is basically a new query language that uses JSONB, and you can access it. And it looks a little bit more like how you would access them within JavaScript, and a little bit less Postgres specific. It still uses the same indexing, and that's the important thing. If you have your JSONB columns with your JSONB indexes, your GIN indexes with JSONB ops, it will just work, and it'll plug into those. There's a bunch of new functions and operators. There are JSONB path exists and path matches and query. And of course, this being Postgres, and particularly in these areas, like these @ question mark, like we have all these funky operators that are really interesting. And now we have more of them. But as an example, just a very quick, I'm not going to go into detail how it works, but for example, this is a JSON path syntax where $.a is extract the key A from my JSON document. And in this case, that's the, let's see, the @ question mark is the JSONB path exists. So this one basically says, does the key A exist in this document? Right? Or in the lower case, does it equal, like the JSON path query is, does it equal 1? So it lets you sort of wrap the entire query inside of the JSON path expression itself. Again, if you are working a lot with JSON, I would encourage you to look into that. And in particular, if you haven't seen it already, look into the video from the JSONPath talk that we had here at this conference. Another thing that we've been doing for a long time in Postgres. Who knew that CTES, so with queries, you might know the common table expressions with something as was an optimization barrier? So who knew that it was? That's, more of you should have known that it was. Because a lot of people would use CTEs because it's also a really nice way to structure your queries to make them very readable. But they also hide a lot of details from the Postgres optimizer. So it can't optimize across the boundaries of CTEs. Or it couldn't optimize across the boundaries of CTEs. And not only is it that it can now do it, it will do it by default. So for those of you who knew that it was an optimization barrier, I saw some well-known faces put their hands up, probably are the people who would then use these as basically query hints. But we don't have query hints in Postgres. But we have CTEs that are optimization barriers, and you could use that as a workaround if the query planner did something you didn't like. You'd wrap it in a CTE, and suddenly you're like, haha, I'm the one who's deciding here, not this stupid planner. And if you do that, that's going to go away. Unless you tell us you really liked to do that, because we're adding a way to do it. So, just as an example, we have a new keyword for CTEs. Now, this is a really, really, really silly example, but it actually works to show this. So I've created two CTEs, right? I have a CTE called T and I have a CTE called T2. They're both exactly the same thing. They're select star from foo. And then my actual query is select star from T, union all select star from T2. And if you look at the query plan from this in a Postgres version prior to 12, it'll look like this. And here's how we see the CTE materialization that Postgres just assumed, well, these are two different things, right? And I'm going to run these two independent CTEs. And I'm going to put an append node that takes the output of CTE scan on T with CTE scan on T2. And it's going to append the results. And it's going to be one row from each because I used a very tiny test table. But at least I put a row in it, not 0. Now, the new thing that we have in Postgres 12 is you can now say, in this case, with T2 as materialized. That'll tell Postgres to treat T2 the way that it used to treat it in previous versions of Postgres, whereas it'll treat T as an optimized CTE. Otherwise, the same query, and when you look at it, you'll notice that the T is actually completely gone in this query plan. Because the optimizer looked at it and said, it's silly to put select star from foo in a CTE. Like, that doesn't actually provide any useful feature, so I'm just going to ignore that and inline that and just run it. But when you explicitly said, but I want you to materialize this, then you get a full CTE scan. Now, by default, Postgres will apply materialize if your query references the CTE in more than one place. But if it doesn't, then it's going to try to inline it in every case. So if you have in your code base places where you are intentionally using CTEs to control the query plan, you will need to put this materialized keyword in there. Otherwise, that optimization goes away. Now, in fairness, you should probably try running your query without the materialize, because maybe you don't actually need that anymore, because other things in the query planner have also gotten smarter since you put that in there. And that's the classic problem of query hints, right? In databases that have query hints, which is you put the query hint in when you need it, but you never take it out. So if you have this, don't just blindly go in and put materialize on everything. Test it, and then put materialize in if you still need it, because it's quite possible that you don't. So moving on, a few quick things about backup and replication. If you are configuring max while senders, the maximum number of replication connections, it is no longer part of max connections. So previously, if you had 100 max connections and 50 max while senders, if you actually used all those 50 while senders, there would only be 50 connections left for regular users. Now, if you put 100 max connections and 50 max while senders, that'll be 100 max connections plus 50 max while senders. So it's just counted from a different pool. And it's dedicated to while senders. That just gives you a better control. But in particular, if you have a high number of while senders, you might need to consider actually decreasing your max connections again, because you don't need them anymore. If you have a low number, it doesn't really matter. Recovery.conf no longer exists. It's gone. I mean, it probably still exists in your repos, but we don't use it. All the settings from recovery.conf have been merged into the main configuration file. Or if you want, they can go in the postgres.auto.conf if you use alter system. So you can now use alter system to configure your recovery parameters. And a few things like that. So if you have any scripts that deal with your recovery or any scripts that deal with setting up your replicas and things like that, you'll have to redo them. Now, I'd say that's an excellent time to look over the tools that are out there. and not write your own. So if you're doing backups, look at the tools like Backrest and Barman for replication. We'll look at those tools for bootstrapping, look at things like Patroni, Rep Manager, and all these things, and maybe retire some of your old scripts that you wrote yourself, because these guys are doing it better, since you have to update your scripts anyway, but you do. So instead of recovery.conf, we now have a recovery.signal. Because the recovery.conf file did two things, right? It controlled how you would do recovery, and the existence of the file would tell the system to do recovery. The recovery.signal file has no content, but if it exists, it triggers the system to enter recovery mode, and then it will read the settings from the main configuration file to perform the actual recovery. So again, scripts, update. Similar, there's now a standby.signal, which does the same thing, but for standby mode. So that would be the equivalent of having a recovery.conf with standby mode equals on. That is similar to doing, creating your standby.signal. Now, why would you change this? Well, one of the reasons is we can now apply the ability to reconfigure things on the fly. In version 12, there are only two things that we can reconfigure. We can change the recovery min apply delay for delayed replication, and we can change the archive cleanup command without restarting Postgres. So if you have a standby server with active users reading data, you can change these things without affecting it. Hopefully that didn't get into 12 is the ability to change the primary coninfo, so basically repoint the standby to a different IP address without restarting it. That didn't make it into 12. Hopefully it'll make it into 13. Because then you'll be able to move your primary role between standby nodes by having another standby server that is actively running queries, repoint itself without terminating or any sort of interruption to these queries. We're not quite there yet, but again, infrastructure for future features. Recovery parameter, recovery target timeline has a new default. That new default is latest. That is probably what you wanted before. You just didn't know it. And a lot of you will have put into your templates that you always wrote recovery target timeline equals latest in your files. That's now the default. And it's the setting that the vast majority of people actually want. There's a new function called pgpromote. SQL function to promote the standby. You connect to your standby, select pgpromote, boom, you're now a master. Don't need to do the pgctl command anymore. If you are using exclusive base backups, so the old style of doing base backups, they're even more deprecated. Eventually, they'll hopefully be removed, but we just keep adding the deprecation level. Almost everyone, I will still claim, who has scripts using this have scripts that don't work. They just look like they work. And there are a lot of dangers with exclusive base backups, which is if you, for example, get a crash and the server restarts while you were running a backup, it's not going to come back up. It doesn't start. That's not great. There are two different ways of doing non-exclusive base backups. One is the low-level way of doing it, which still uses SQL functions, but scripts have to be updated to use them. Or you can use PG-base backup, which will also do that. But if you look at any of the big backup tools like Backrest and Barman, they don't use this anymore. They did at one point, but they stopped years ago, and they're using the non-exclusive version. So if you're doing your own scripts, you should really look at using the non-exclusive version. It's much, much safer. Yes? That is also a very good point. You should not be using your own scripts in the first place. There are cases where you have to use your own scripts, but if you don't have to, don't do it. Just go look at what things like Backrest and Barman do, and then consider how many of those special cases you thought of. And if it's like more than 2 out of 500, you're better than average. So, final section, performance. A couple of smaller things. If you're using space partition, who's actually using space partition gist indexes? Anyone? 1? 2, 3, okay, that's good. They now support KNN searches. Who's using KNN in regular gist today? You might not even know it. KNN is the K nearest neighbor, so it's basically you can use the gist index and now the space partition gist index to do order by limit on things like distance within your gist, and that also now works with space partition gist. Gist, GIN, and SPGist will now generate a lot less wall during index build. It's one of those good performance improvements that it just will. You don't have to do anything, nothing changes, it's just faster. unless, well, everybody's happy. This is that's a shortened version of what it's actually called. It's the partial detoast of compressed datums. Everyone knows what that means, right? What it means, previously, if you had a large value in Postgres, such as, and the reason that this was written in the beginning, like a large geometry in PostGIS, even if you only wanted to read the beginning of it, Postgres would have to read the whole thing, uncompress it, and then read just the first beginning of it, because these are automatically compressed. The exception being like substring. You can do some things with that, but nothing else. The way that it's been optimized is that these other APIs can now tell the system basically, I only need this much, and it'll only decompress that much. And this can in particular, what we know already is that it can be a big win for PostGIS, because PostGIS often has large structures going in. That's the main reason. It's going to show up as useful for other things as well, but in particular for things like PostGIS. I'm not going to go as far as say that we've fixed the final thing on partitioning, but we've fixed one of the really big hurdles on partitioning. First, we've added the ability to do flexible partition bounds, which is sort of going back. When we had the old style partitions, you could do anything. Then in Postgres 10, we added declarative partitioning, and we've restricted a lot of what you could do, and we've now enabled a little bit more, so you can do range partitioning based on expressions and not just values. Performance-wise, a huge difference in partitioning is how locking is done. In Postgres 11 and earlier, when you ran a query that ran on one single partition, as it planned the query, it would actually lock all your partitions. So if you had 10,000 partitions, it would lock all 10,000 of them and then read one. The locking has now been postponed until we actually read the partition, which means if we can identify our data to be in a single partition, we'll just lock that partition and not the rest. And of course, we'll lock the master table so you can't drop it while we're reading it and things like that. This can lead to much, much, much faster index scan, partition scans, particularly when a large number of partitions involved. It can make a really huge difference. Yes?
Or is it able to delay that locking if you have multiple partitions, but as long as you're telling it which partitions it is? So if you knew that you needed to hit 2 of your 10,000, it could still delay that until it has to scan them?
Yes. It's basically, it will always delay it until it scans them in every single case, regardless of. So if you have 10,000 partitions and you need to scan 10,000 partitions, it'll delay the locking until it actually scans them. But of course, it will still have to lock them. So there's no limitation on that. You can also now attach a new partition to your table without taking an access exclusive lock. There are use cases where that becomes really, really important, but the first one I think is the most important one around that. If you copy data into partitions, for some reason previously, Postgres didn't use what we call multi-inserts. They would actually open the table and sort of inject the tuples one by one into the table access manager. It now uses multi-inserts. It's just faster. That's all we need to care about. Copy is faster. But the really big thing that I find is you can now have a foreign key that references a partition table. And this is one of the, like partitioning, the point of partitioning is they should be transparent to your application. And then we say, well, as long as you don't have foreign keys. And it's like you should be able to have foreign keys in your database. Now in Postgres 11, you could have foreign keys from your partition table referencing another table. But you couldn't have foreign keys on other tables referencing into the big partition tables. Now you can, as long as the partition table has a primary key, but that you can't reference a table that doesn't have a key at all. And having a cross-partition primary key has some restrictions on what the primary key must look like. They obviously still apply here. That is that the partition key has to be part of the primary key, because otherwise it just wouldn't work. That is still there. But this sort of unlocks a whole bunch of cases where you just couldn't use partitioning before. Without, I mean, we don't want to remove our foreign keys from the database. It's kind of one reason why we have the relational database. Serializable, the serializable isolation level is now compatible with parallel query. Previously, if you if you set your isolation level to serializable, you would never get a parallel query. And, well, now you will. So obviously, if your workload is one that benefits from parallel query and requires serializable, it'll be a lot faster. Expression JIT compilation was in Postgres 11, but turned off by default, and you had to go in and turn it on. In 12, it's turned on by default, so keep an eye on your queries. There might be cases where they run slower because of it, then you'll have to go in and turn it off. But the reason that it's turned on by default is that we believe that it will help a lot more than it will hinder. And experience shows that it will. So that's a lot of features. There is, of course, a lot more than this. I mean, this is sort of a laundry list of the biggest feature or the features that I liked. If there are contributors, I see there are a number of contributors in the room. If I forgot to mention your feature, I'm sorry. You know, come heckle me later. I probably should have, but there's a limit to how much you can say. There's always more. There's a lot of smaller fixes. There is a lot of performance improvements. Obviously, there are also bug fixes. They have hopefully been backpatched. But in particular, certainly now that we've reached the level of beta 4, we need your help, every one of you. And we need your help to download and test this version. Because without knowing, like, that's the whole point here. You tell us now what's wrong, and we can fix it before we release. It's a lot easier to fix it before we have released. It'll also help you, because then you will be able to upgrade once we have released, because you've already tested and told us what was broken and we fixed it. The beta 4 is available on app packages, it's in RPM packages, it's for SUSE, it's Windows installers, like all of these things are available. So it's really easy to install. You can use PG Upgrade to upgrade your machines. Now, you might not want to upgrade your production to this yet, depending on who you are. Robert's famous for putting versions in production that nobody else would even consider. But if you have, say, CI systems, put beta 4 in your CI systems. It'll run all the time, and you can let us know how it worked. If you have a test suite for your own systems, run it against Postgres 12 beta 4 and let us know if it broke something. Let us know if, well, of course, outright, if we broke something and it doesn't work. We're also interested in knowing, did it run slower? Did something become slower in version 12? Obviously, we don't intend for anything to be slower, but it could happen. And we want to know about that. And of course, we're also interested in the fact that you ran it and it worked, because then we know that you ran it. And that gives us more confidence in that what we have has actually been tested for real. And running those types of tests doesn't have to be hard, right? Just run it real quick. Even the small part helps. If you have developer systems or full-on staging systems and things, if you're willing to run our beta versions on that, that's obviously even better. Like, the more testing we can get, the better. We don't think there is much left until version 12. Of course, there's no guarantee. If you start building something in your application using one of these new features that actually includes changes to your application, yes, we may remove that feature before the release. We reserve the right to do that. We have reached beta 4. It's unlikely, except for this progress meter thing. But it's unlikely that it's going to be removed. There is a risk. It's always a risk, which is why putting it in production can be slightly scary. That's all I have. I think I have approximately 1 minute for further questions. So any further questions? Robert?
When you say we shouldn't upgrade production to beta 4, you're saying we should leave it at beta 3?
Yes, you should leave production at beta 3. Don't go to beta 4 yet. Anyone else? Yeah, you can all hear lunch back there, right? That's what it's all about. In that case, I will say thank you for your attention. Feel free to grab me. I'll be here the rest of the conference. Just grab me in the hallway if you have any further questions or feedback on version 12 or anything else. And other than that, enjoy lunch. Thank you very much.